Hi, it's Dr. C, and today we will be going over how to do a confidence interval with proportions. So first things first, we have this question. It says on a sample of 330 adults. It distinctly gives us our sample size, and then it gives us our X value. We are to do a 90% confidence interval. Um, there you go. And so that's essentially all it gives us, which doesn't seem like much, but that's all we need to solve for a question like this. So given we have n equals 330, x equals 241, and then I'm just going to put alpha. So essentially, if we are 90% confident, that means that we are 10% not confident. So alpha is going to be 0.10. Okay, so first thing, you essentially are going to write out the relevant formula. So the relevant formula here is going to be p hat plus or minus z critical times the square root of p hat times 1 minus p hat over n. So if you notice, we don't really have p hat, but we have all the elements for p hat. P hat equals x over n. So 241 out of 330 equals 0.73. So we have the p hat, we have n. What we don't have is z critical. I do have a z critical value table here on the board. You can solve it for a multitude of ways. You can use your calculator, you can use Excel. So we know that based on the 90%, our z critical essentially would be 1.645. So we're just going to write that here under our givens. Plus or minus 1.645. Okay, so now we have all the elements needed. So we're just going to fill them in. So 0.73 plus or minus 1.645 times the square root 0.73. 1 minus 0.73 is 0.27 over n, which is 330. So my advice will be to solve margin of error. Margin of error is literally nothing more than the z critical times the square root of the p hat times q over n. So when we solve that, 1.645 times the square root of 0.73 times 0.27 divided by 330, that gives us 0.0402. So 0.73 plus or minus 0.0402. So your next step would be to solve for the lower and upper bound. Okay, lower bound is minus, so you would do 0.73 minus 0.0402, and your upper bound is 0.73 plus 0.0402. So when we put that together, 0.73 minus 0.0402, we have 0.6898. And then the upper value is 0.7702. So I notice it says round your decimals to 3 places. I'm assuming it meant to 3 places. So we can round this to 3 if that's easier. So the way that you would write this essentially, we have our P, so 0.69 and then 0.77. So your answer, we essentially are 90% confident that our population proportion, or the true population proportion, is between 0.69 and 0.77. I hope you found this video to be helpful. If you have any additional questions, please feel free to let me know. Okay? Take care.